So we're going to review types of problems you can expect to see on your Module 5 test. So number 1, we're given tangent of theta is 5/6. We want to find the value of the other 5 trig function values. So when we're given tangent, we're going to go ahead and draw the triangle with our given information. So we have a right triangle, and I'm going to locate theta as the lower angle. So we know tangent is 5/6. And if you remember, tangent is opposite over adjacent, which means we know our opposite side is 5 and our adjacent side is 6. In order to find our other 5 trig function values, we're going to need to know the hypotenuse. So we're going to have to use the Pythagorean theorem. So we know 5 squared plus 6 squared is going to equal c squared. So we end up with 25 plus 36 equals c squared. So we have 61 equals c squared. Take the square root of both sides, and we get c equals the square root of 61. So now that we have all 3 sides of our right triangle, we can find our other trig ratios. So we're going to start with sine. So sine of theta is opposite over hypotenuse. So our opposite side is 5. Our hypotenuse is the square root of 61. So we get 5 over the square root of 61. And if you rationalize the denominator, that's the same thing as 5 square root of 61 over 61. Next, we're going to look at cosine of theta, which is the adjacent side over the hypotenuse. So our adjacent side is 6 over our hypotenuse square root of 61, which if you rationalize the denominator is going to be 6 square root of 61 over 61. Our next trig ratio would be tangent, which we already know, so we don't have to find it. All that's left is our reciprocal trig ratio. So cosecant of theta is the reciprocal of sine, which is going to be the square root of 61 over 5. Secant of theta is the reciprocal of cosine, so it's going to be the square root of 61 over 6. And cotangent of theta is the reciprocal of tangent, so it's going to be 6/5. And that is our other 5 trig function values. Question 2, we're given if the angle of elevation to the top of a building is 80 degrees and you know the building is 200 feet tall, how far away from the building must you be standing? So if we go ahead and draw what we know, we have a building and we have someone standing at a certain distance. They're looking up at the building at an 80-degree angle. We're given that the building is 200 feet tall. And we want to know how far from the building you must be standing. So that's going to be the distance along the bottom. So we're going to use a trig ratio to solve for x. From our 80-degree angle, the 200 feet is the opposite side, and the distance you are away from the building is the adjacent side. So we're going to use tangent. So we know tangent of 80 degrees is going to equal our opposite side, 200, over our adjacent side, x. So now we need to solve for x. So the first thing we're going to do is multiply both sides by x to get it out of the denominator of our fraction. So we have x times the tangent of 80 equals 200. Now to get x by itself, we're going to divide by the tangent of 80. And now it just becomes evaluating in our calculator. And always make sure that your calculator is in degree mode before you plug it in. So 200 divided by the tangent of 80 is going to give us 32.27 feet. Okay. Number 3, we want to find the exact value of the following by any method you choose. So we look at our first example. We want to find the cosine of 1,305 degrees. So the first thing I'm going to do is to find the angle between 0 and 360 that is equivalent to 1,305. So the way you do that, if we take 1,305 and we subtract 360 until you get an angle between 0 and 360 degrees, you end up that 1,305 degrees is equal to 225 degrees, which, if you have your unit circle handy, is that angle measure on our unit circle. And it's specifically the point negative radical 2 over 2, negative radical 2 over 2. But we want cosine. And if you remember from the unit circle, the x value is equal to cosine and the y value is equal to sine. So our x value here is the square root of 2 over 2. So I know cosine of 1,305 is equal to negative radical 2 over 2. So we're going to do something similar for our next example. We want to evaluate 2 sine of pi over 3 plus 1/3 secant negative 3 pi over 4. So I know pi over 3 is the point 1/2 square root 3 over 2. And again, this is using the unit circle. And negative 3 pi over 4 is going to be the same thing as 5 pi over 4. So negative 3 pi over 4 is the same thing as 5 pi over 4, which is the point negative radical 2 over 2, negative radical 2 over 2. So now we're just going to replace the trig function with its value. So sine of pi over 3, from the previous problem, we know sine is the y coordinate. So sine of pi over 3 is the same thing as radical 3 over 2. So it's going to become 2 times radical 3 over 2 plus 1/3. And then secant, if you remember from problem 1, is the reciprocal of cosine. So we're going to take our cosine value, which is the x coordinate, and do its reciprocal. So we're going to get negative 2 over radical 2. Now we're just going to work on simplifying. So 2 times radical 3 over 2, the 2's are going to cancel, so we'll end up with radical 3 plus, and negative 2 over radical 2, I'm going to go ahead and rationalize it, is the same thing as negative radical 2. So I'll show you off to the side here. So if I take negative 2 over radical 2 and rationalize it by multiplying by radical 2 over radical 2, we get negative 2 radical 2 over 2. And negative 2 over 2 is just 1, so we end up with negative radical 2. So if we go back to our problem, we have radical 3 plus 1/3 times negative radical 2. So we get radical 3 plus, and a positive times a negative is going to get us a subtraction, so minus radical 2 over 3. Now we could leave our final answer in this form, but we always like to write answers as single fractions. So this is technically radical 3 over 1. So I can multiply my fraction by 3 over 3, so it'll have a common denominator. So we'll get 3 radical 3 over 3 minus radical 2 over 3. Writing it as a single fraction, we get 3 radical 3 minus radical 2 all over 3. And that is going to be our final answer. So in problem 4, we're given the point 1/7 4 radical 3/7 is on the unit circle and on the terminal ray of our angle theta. We want to find the value of our 6 trig functions. So this is kind of similar to one the combining problem, the first problem and the last problem. So x is going to be cosine and y is going to be sine of theta. So we know that sine of theta is equal to 4 radical 3 over 7. Cosine of theta is equal to 1/7. Next, we want to find tangent of theta. So we can tangent is equal to sine divided by cosine. And if we notice, both of our fractions have the same denominator. So when we're dividing two fractions with the same denominator, we're only dividing their numerators. So we want to divide the numerator of sine and cosine. So that's going to be 4 radical 3 divided by 1, which is just 4 radical 3. Now we're going to do our reciprocal trig function. So cosecant of theta is the reciprocal of sine, so it's going to be 7 over 4 radical 3. Secant of theta is the reciprocal of cosine, so it's going to be 7. And cotangent of theta is the reciprocal of tangent, and that's going to be 1 over 4 radical 3. So in our last 3 problems, we're going to be using either the law of sines or the law of cosines to solve our triangles. So in our first, in problem 5, we're given one angle and 2 sides. So this is that ambiguous case of the law of sines where you first have to determine if we even have a triangle that can be formed, one triangle or 2 triangles. So we're given that angle B is 15 degrees, side B is 14, and side A is 20. So in order to determine if we have no triangle, 2 triangles, or 1 triangle, we want to compare the side whose angle we're also given to our second side. So in this case, we're comparing B and A. And B is less than A. So we actually need to find the height of our triangle to determine our solutions. So the height is going to actually be A times the sine of B. So it's going to be 20 times the sine of 15. So our height is 5.18. And our side B is greater than H, which means we have 2 possible triangles for our solution. So if we set up what we already know using the law of sines, we have sine of A over 20 equals sine of 15 over 14 equals sine of C over C. So we're going to use the law of sines to solve for angle A first. So sine of A over 20 equals sine of 15 over 14. We're going to multiply both sides by 20. So sine of A equals 20 times the sine of 15 over 14. Then we're going to take the sine inverse of both sides. So this is going to give us angle A. So we get that A equals 21.7 feet. Sorry, this is the angle. So this is going to be 21.7 degrees. Now we can find angle C by doing 180 minus 15 minus 21.7. So we get C can equal 143.3 degrees. So now we want to find side C. So we are going to use sine 15 over 14 equal to sine 143.3 over C. Cross multiply. C times the sine of 15 equals 14 times the sine of 143.3 and divide by sine of 15. So side C is 32.33 feet. So that's our first triangle solution. Now we need to find the second triangle solution for angles A and C and side C. So to find our second possible measure for angle A, we're going to do 180 minus 21.7. So our second solution for angle A is 158.3 degrees. Now to find our second solution for angle C, we're going to do 180 minus 158.3 minus our original given angle of 15. And our second solution for angle C is 6.7 degrees. Now to solve for side C, we're going to set up our ratio using sine of 15 over 14, and this time setting it equal to sine of 6.7 over side C. Cross multiply, we get C times the sine of 15 equals 14 times the sine of 6.7. Divide by sine of 15, and we get C equals 6.31 feet. And those are all of the possible solutions for our triangle. Problem 6, we want to solve triangle ABC and we want to solve for our three angles. So when we're given all three sides, we use the law of cosines. So we're going to use the law of cosines to solve for one angle. Then we use the law of sines to solve for a second angle, and then we use the triangle sum theorem to find our third angle. So it doesn't matter which angle you choose to solve for first because you're given all three sides. So I'm just going to choose to solve for angle A first. So I'm going to use A squared equals B squared plus C squared minus 2BC times the cosine of angle A. I'm going to use that to solve for angle A. So plugging in what we know, so 9 feet is side A because it's opposite angle A. 3 feet is side B, and the 8 feet is side C. So plugging that into the law for our law of cosines, we have 9 squared equals 3 squared plus 8 squared minus 2 times 3 times 8 times the cosine of A. 81 equals 9 plus 64 minus 48 times the cosine of A. So get 81 equals 73 minus 48 cosine of A. Subtract 73 from both sides. We get 8 equals negative 48 times cosine of A. Divide by negative 48. And we want to leave 8 divided by negative 48 as a fraction in simplest form. That's going to give us negative 1/6. Now we're going to take the cosine inverse of both sides. And that's going to give us that angle A is 99.59 degrees. Now that we know one of our angles, we now use the law of sines to find a second one. So we have that sine of 99.59 over 9 equals sine of B over 3 equals sine of C over 8. Again, you have an option. You can either solve for angle B or angle C. I'm going to just go ahead and keep following the order. I'm going to solve for angle B. So sine of 99.59 over 9 equals sine of B over 3. Multiply both sides by 3. We get sine of B equals 3 times the sine of 99.59 all over 9. Take the sine inverse of both sides. And in this case, 3 and 9 can actually simplify. So I'm going to go ahead and simplify it. So we're basically taking the sine inverse of sine of 99.59 over 3. So we get that B is 19.19 degrees. So now that we know two of our angles, we can just use the triangle sum theorem to find angle C. So we do 180 minus the 99.59 minus 19.19, and angle C is 61.22 degrees. So our last problem, we are given points A and B are on opposite sides of the Grand Canyon. Point C is 200 yards from A, angle B measures 87 degrees, and angle C measures 67 degrees. What is the distance between A and B? So it's going to be helpful if you draw a picture with what you're given. So we have points A and B on opposite sides of the Grand Canyon. So A and B. And we're given an arbitrary point C that is 200 yards from A. So we know this distance is 200 yards. We're given that angle B measures 87 degrees and angle C measures 67 degrees. And we want to find the distance between A and B. We're looking for this value X. And my picture is obviously not drawn to scale. Yours doesn't have to be either, as long as you have the correct picture that represents the situation you're given. So we want to determine if we want to use the law of sines or the law of cosines. So I'm going to go ahead and find angle A just to help decide between which one I want to use. So 180 minus 67 minus 87. It's going to give us that angle A is 26 degrees. Okay. So we were trying to determine between law of sines and law of cosines. With law of cosines, you have to either be given all three sides or two sides and an angle. And in this case, we're only given one side. So we're going to go ahead and use the law of sines to solve for the distance between A and B. So in this case, the 200 yards is going to be side B, X is going to be side C, and BC is going to be our side A. So setting up with what we're given, we have that sine of 26 over A equals sine of 87 over 200 equals sine of 67 over x. You could use c there. I'm going to use x since that's what I originally labeled the angle. So we want to use the ratio that we're solving for and the one we're given. So we're not going to use the sine of 26 over a. So we're going to set it up as using sine of 87 over 200 equals sine of 67 over x. Go ahead and cross multiply. So we get x times the sine of 87 equals 200 times the sine of 67. Divide by the sine of 87. And we get that x is 184.35 yards. So hopefully now that you've completed these problems, you're prepared to take the Module 5 tests. If you have any questions or any, make sure you ask before you take your test.